Hey, so I'm going to be talking about model evaluations, particularly in the context of large language models and AI safety. And most of these ideas will be based off of these two blog posts by a dude named Marius written about a year or so ago. And so in brief, an eval is short for an evaluation, and Marius defines it as the systematic measurement of properties in AI systems. So at a high level, we have like some AI system, which usually is just like some large language model in our case, but you can also include like some fixed system prompt, or maybe this LM can call tools like a calculator or something. But at the end of the day, you can more or less just think about it as like there's some ML model and we want to evaluate it for something. And also in my definition of this, and I think a fairly standard definition, the model weights in your evaluation are frozen. And so you're not like doing any training or anything. You just have like some fixed model and you want to do something with it. And I think an important distinction is that for non-safety and non-large language model related machine learning research, the flavor of evaluations is fairly different. As an example, for a standard like traditional machine learning model training and evaluation process, you can have something like a cat dog image dataset, and you can have like labels associated with this. And our goal is to train some model, say a CNN, on the train split of this cat dog image dataset. And then after you finish training it, you evaluate the same CNN on the test split of the cat dog dataset. And in other words, you're evaluating your training procedure, uh, the model architecture, on some dataset, and this just makes sense because obviously like you want to know like how good is this training procedure and this architecture on this particular task of interest. Um, a caveat is that sometimes there's other somewhat more strange things that you're evaluating for. For example, in the context of adversarial robustness, sometimes you may want to do something like evaluate how robust this model is against input perturbations. Um, for the cat dog image dataset example, maybe you have like you train some CNN on the train split of this cat dog dataset, uh, but in your evaluation, you don't evaluate it on the same cat dog dataset. You evaluate it on a noisy version of the cat dog dataset, say by applying like some algorithm to add some noise to each of the input images, and then you evaluate how good your training procedure and your model architecture is um, on this particular classification task with noise in the inputs. So this is a little bit different than like a standard train on the same distribution as what you're testing on, but uh, most of the time it just follows this first case. But in the context of like large language models, the training and evaluation pipeline is almost entirely different than the traditional ML sense because the objectives that you're training for are very, very different than what you're usually evaluating for. Uh, in detail, in the training procedure of like a large language model, there's often a series of different steps involving data that is almost entirely unrelated to the evaluation tasks that most people are interested in. For instance, for large language models, you usually have like some pre-training with like some autoregressive next token prediction objective. You have like some supervised fine-tuning objective. Then you have like some RLHF objective. But what you're evaluating for in the end usually is something like, can it answer a math question, which is not related to predicting the next token, which is like measured by something like perplexity. Uh, yeah, and so because like LM training and evaluation doesn't follow the standard pattern, we sometimes have to use different definitions. And this is something that like the field in general isn't super advanced in at this point. Like I still don't think there's like a super well established nomenclature for like how all this uh, evaluation terminology actually works. But at least I'll be referencing this guy's definitions. So in the context of like large language models and safety, we're usually evaluating along two different axes, one of which is capabilities, and the other of which is propensity. And so capability research can largely be thought of as whether or not some large language model is capable of completing a task. For example, maybe I'm trying to evaluate on a math dataset, and I want to see that my large language model is capable of answering the questions maybe like 10% of the time or something. In contrast, propensity is how likely is the large language model to do something. Uh, and I guess the key distinction between these two things that we're evaluating for is like under what sort of conditions. For capabilities, we're often doing like uh, worst case analysis, whereas for propensity, we'll be doing like average case analysis. And I'll expand on this in this next point. So in terms of definitions, there's also a distinction between red teaming and benchmarking. Um, red teaming, as defined by Marius, is sort of actively looking for specific capabilities while interacting with the frozen model. And this is more of like an existence proof or worst case slash best case analysis, in which we're often trying to maximally elicit some behavior. But this isn't exactly the same as making a claim of how likely this model is to do something in real world, in like real use situations. In contrast, benchmarking sort of measures the likelihood of a model to behave in a certain way on a particular data set, and this is more aligned with the traditional idea of benchmarking. And this can be thought of more as like an average case and representative of real use conditions. To give a concrete example of like what this may look like in practice, right, slight technical difficulties have since been resolved. Yeah, so if like the language model is capable of telling me how to make a bomb, that's like pretty bad. And we want to know if it's possible under any circumstances for this large language model to produce an output that is considered dangerous. And this sort of leads into the second blog post, which is called We Need a Science of Evals. And the high level idea is that because evals are used in very high stakes situations, for example, I think that a lot of frontier safety labs, they rely on evals to consider whether or not they're going to deploy a model. Like they need to ensure that this model, under a bunch of different adversarial prompts, does not do these bad behaviors. Yeah, because these evals are used in very high stakes situations, it's necessary that there's more rigor and scientific processes before in their development and their uses. As one example that's highlighted in this paper, again, like large language models are very sensitive to the prompt. And because evals often try to estimate an upper bound of the capabilities rather than the average capabilities, we want to know how to maximally elicit these behaviors. So I guess two open research questions are one, are we measuring the right thing? And the second is like, how do we quantify or know for sure that we're measuring the right thing? As an example by this figure here, perhaps we're interested in the space of all math questions. So we want to know like how good our language model is at answering across the entire space or the true distribution of math questions, but we're evaluating only on a small subset, which say contains like only trigonometry questions. And the second thing is like how trustworthy our results are, because it's possible that like with different prompting strategies, you can get different results, and there's currently not too much rigor in this field in terms of how we obtain these results.